Hello everyone, welcome to IGBits. We train, you learn. How are you all doing? In last class, we reviewed some of the cases on concept of Newton's laws of motion. We shall continue explore few more cases as a concepts and then problems in today's class. Without further delay, let's get started. We created a YouTube channel which does that our YouTube channel @IGBits. Feel free to subscribe the channel. We started uploading all our sessions in YouTube. You can utilize this opportunity and build your competency. All right? Yeah, thank you. Let's look at concept called a balanced forces versus unbalanced forces. Let's assume you have a block or a body of mass m. So we have two states that we talk about in the force, right? According to Newton's laws of motion, inertia of rest, inertia of motion. What we see here is when the body is at rest on the surface, the forces acting on it. What are the forces acting on it? A gravitational force which is in downward direction, Fg equal to mg, and a contact force, a normal force which is upward direction, right? Which is how you denoted Fn. So Fn and Fg, right? If they both are equal in a magnitude and opposite direction, then the net force would be Fn minus Fg equal to 0, Fn equal to Fg, but opposite direction, right? So let me reiterate. If the resultant force of all the forces acting on the body sums up to the 0, then the forces acting on the body is known as the balanced forces, which is what I'm talking about. Fn minus Fg equal to 0, right? So what that means, the forces are equal in magnitude. It does not cause any change in state of motion of the object, because if the both forces are equal, your net balance would be 0, and hence we are not actually seeing any change in the state of the object motion. That is how it is. Then what is meant by unbalanced forces? You can see the one noticeable parameter is acceleration. Object might accelerate if you apply unbalanced force. Correct? So if you apply a force, then towards the right direction, that means like you body tend to move to the towards the right direction, right? So that is how it should be. So let's reiterate. An object initially at rest may starts moving upon extracting unbalanced force on it. Make sense? If the body is already in motion, then the magnitude of its velocity may increase or decrease, right? Or direction may also change. These are the few things that we can think of. So when you are applying a forces on the body, what are the forces that are act upon? How do you understand which is a balanced forces and which are unbalanced forces? Accordingly, we will figure out a acceleration towards to which direction of the body depends upon the force that we applied. This concept is not new. We have seen some of the problems in the previous class. So by reiterating one more one more time, this would actually help you to recall things that you did, and then some are things you can get clarified in today's class too. Okay, this is good one. All right, I hope you're clear. Let's move on to next topic then. Body diagram. A free body diagram consists of a diagrammatic representation of a single body or subsystem of bodies isolated from its surrounding, showing all the forces acting on it. So when you are solving a problems, FBD diagram helps us to analyze the problem and then solve the problem easily. It is very simple if you understand the basic concept. Let me reiterate. A free body diagram is a graphical illustration used to visualize the applied forces, momentum, resultant reactions on a body in a given condition. It depicts a body or connected bodies with all applied forces and momentum and reactions which acts on the body. A free body diagram is used to show the relative magnitude and direction of all the forces acted upon the object in a given situation. A free body diagram is a special example of vector diagram. See, one way or other, all these lines describes one thing, right? You are visualizing, diagrammatically representing the actual system, so you can understand what are the forces acting upon and what direction. Make use of that, you will be able to analyze the problem and solve the problem for a given ask. Right. Let's say, for example, I have the block of mass m which rests on the table. What we are saying here is, what are the forces which are acting upon the body? One for sure we know, weight, which is always downwards. This is called Fg, force due to gravity. Is it? So that is how you are representing. Your mass becomes like a rectangular box of mass, and then so if you look at this mass, this block connected with this table, so there is a the force which exists perpendicular to your contact surface, what you can call it as a normal force, which acting upwards from the connected surface towards to the body, right? So that's why we are showing this as a upward direction, Fn. So now Fn and Fg are equal in magnitude, opposite direction. That's why we are saying this block is at rest state on this context. Is it? Look at this perspective. When two forces are acting upon the body, one is a normal force, other one is like gravity force. This is how we are representing. Normal force towards the upward direction, because the contact surface which acting on a body towards to up, whereas a gravity is always a downwards, right? But there are the cases where if we apply the external force on a body to move, that's what we call it as a applied force. If you consider a frictional force, the frictional force is always opposite to your applied force, and hence I am representing right side. If I am applying a force on a block, then opposite direction would be the left, towards the left side, the frictional force acting on the body. So that's why my FBD shows like this. These are very useful, the tools and techniques to visualize the given problem and then solve the problem towards the solution. Let's draw FBD diagram for finding a normal force. This is easy one, right? You can draw. What you do is like this is a block of mass m, surface contact. Due to the surface contact, the normal force acting on body upward direction. That's why we are saying this is Fn. We know this weight mg, acceleration due to gravity, we have a Fn, right? Fg, gravity, force due to gravity is mg. This is downward direction. So net force would be Fn equal to mg in this case. Clear? Draw FBD diagram for this. What we have seen this like m1 and m2, one on top of other, which are on surface. Let's say, right? So now you have to identify each one. Take a first case is m1 block. Think about what happens here. Surface contact is this much, right? So m2 is like m2 should show a normal force on m1 is upward direction. So what you have to see, this is called your Fn, right? Whereas downward is m1g. So FBD for m1 would be this much. Let's take m2. How many surface of contacts we have? Contact surfaces. We have two contact surface for m2. One is this one, upward direction. Due to m2, one more contact surface, downward direction. Right? So let's look at both. I would say this is n1 and this is n2. So representation would be your n1 is a downward direction, your n2 would be upward direction, and then you have always mg down. So what would be now? n2 equal to n1 plus mg. Upward, summing of all upward forces equal to summing of all downward forces. That is how I am representing for this minute. But what about here? So Fn is also called n1 for simplicity, right? So now n1 equal to mg in the first case. Now in second case, n2 equal to n1 means like mg, right? So here m1, this would be m2. So m1g plus m2g. So n2 would be m1 plus m2 of g. This is the n2. Are you clear? I am repeating. So when we have two masses, one on top of another, so then obviously we have to see like a contact surfaces. How many contact surfaces we have? Between m1 and m2 we have one contact surface, and hence one normal force which act upon the body, right? So this case would be for m1, whereas in m2 we have a two surface contacts, right? M1, between m1 and m2 you have one surface contact, m2, and then the floor would also be the second surface. So we have a two contact surfaces. This is what you can call it as a contact surface. Similarly, this portion is also contact surface. Clear? So n2 is upward direction, n1 is downward direction, m2 and g would be your force due to gravity. So summing them all, upward direction force is equal to downward direction forces, and then in n1, in place of n1 I am replacing m1g, right? This is m1g. So m1g plus m2g, so m1 plus m2 into g would be your n2. So n1 and n2, you get it. So this is easy, right, to solve the problems now. So advantage, if you are able to actually draw a free body diagram, then you can identify all the forces, you can balance them to get a final answer. Let's try out this one. Let me open my pen. Okay, so let's take the case one. 2 kg mass, right? 2 kg mass. So the surface contact, what we have is one surface contact. This is a second surface contact. Let's say this is n2, this is n1, right? n1 is upward direction, n2 would be downward direction, right? And then we have mg here, we have mg here. So let's see one by one. For the 2 kg mass, the upward direction is n1 and then mg is down. So if you take g equal 10 for our simplification, then n1 would be 2 into 10, so 20 newtons. Take the second case, 6 case block. What we are saying is like n2 is upward direction, n1 is downward direction, and then m2g means like 6 into 10, 60 Newton downward direction. n1 would be 20. Just now we calculated. So how much n2? 20 plus 60 equal to 80 newtons. See how easy now? Alright. Let's look at now inclined plane case. We have a block of mass m which is on inclined plane. So we know that this is a contact surface. Due to contact surface, we have a reaction force that is also called as a normal force, which is perpendicular upward direction from the contact surface. Right? Due to contact surface, the force applied in the block m would be perpendicular to contact surface upward direction, whereas force due to gravity Fg should be always a downward direction, Fg perpendicular downward direction. Let's say this inclined plane of angle theta, then you can extend this further here, right? This would also be a theta. If this is theta, what would be this value? This is mg, right? Mg is actually is a resultant force for this inclined plane, the horizontal component, vertical component, what we get it. So this one would be your mg cos theta, whereas one more force this direction, if you can extend like to understanding, so this would be mg sin theta, right? So what are the forces which are balanced? Fn balanced with mg cos theta, Fn balanced with mg cos theta. Clear? Inclined, this is a one differentiator you have to understand. So now let's say block is moving also in the downward direction, right? If you don't have any backward force applied, then your net force would be your acceleration at which the block is moving downward direction, right? Would be ma. So now applied Fa would be your mg sin theta, correct? No, means like m into a equal to mg sin theta. So that means a equal to g sin theta. So you can calculate g value if you know, calculate acceleration value, acceleration of the block towards to downwards would be a equal to g sin theta. Are you clear? Alright, let's give a try. Draw FBD for this given scenario. So we have two strings which are tied at the end, you know. Then we have to identify all the forces to it. How do you represent now? Let's say this is tens force, right? Because of the string, we say this is tens, and then this would be towards the upward direction. If we can put a block here, M, then what you are representing is you are calculating tens T1 towards to upward direction, and it's making an angle with theta. This T1 would actually resultant of two components, horizontal components and vertical components would be, right? So that is what your representation. What would be this one? This is T1 cos theta. This is T1 sin theta, right? And then mg is always downward direction. Now there is a one more string. So what would be the force here? This would be T2. Now we know how to balance. Both horizontal would be balanced, both vertical would be balanced, right? This is horizontal, this is vertical, right? So T1 sin theta equal to mg. This is one equation. Similarly, if you look at this one, T2 equal to T1 cos theta. If we calculate T1, then you would be knowing T2. Clear? So it's very easy, no? If you understand the FBD, you should be able to solve the problems. That's why I'm saying this is the best tool, representing things in the graphically and identifying all the forces and then balancing all the net forces of, for a given problem statement. You will be able to figure that out, how to solve the problems. So let's draw a FBD diagram for this given. We have, this is a string we connected at one place, so that we have it, because you're talking about a string, we have a tens force T. The T is always in upward direction because this is where I think you're tying up, right? So upward direction, and then M2 is greater than M1, so a tendency to move M2 block is downward direction, that is for sure, right? Because M2 is high, it will pull down. M1 is upward direction, right? Now how do you do the case 1? Your case 1, draw a FBD for M1, identify the forces. T would be upward direction, and then M1G is a downward direction. Acceleration should be in upward direction, right? This is nothing but force M1A, right? Since this block is moving upward direction, T would be higher than M1G, right, for calculating the net force. So T minus M1G would be M1A. This is equation 1. Agree? Let's take about it case 2. Case 2 is a block 2, M2. Right? Create an FBD for this one. So for first thing is like tens is upward direction, and then M2G downward direction, but your block is moving downward direction, right? When the block is moving downward direction, that means this force would be M2A downward direction. So how do you calculate the equation? Net sum would be net force M2G minus T equal to M2A. Agree? This would be your equation 2. This is equation 1. Let's say add the equation 1 and 2. What happens? This one and this. So you can get how much? We have a t replacer. So t equal to how much? m1 plus m2 a plus g, right? T equal to, in this case, m1 into a plus g. Correct? So if we can replace here m2g minus m1 of a plus g equal to m2a, and hence m2 blocks we can move. So m2 equal to g minus a equal to how much this one? m2g, right? This block is up this direction, so m1 of a plus g. Am I missing something here? So what we wanted is we have to calculate the a value. So we have to make a point, this a should be taken out. No, this is wrong, right? So here m2g minus m1a minus m1g minus it's like m2a, right? So m1 and m2g, you can take g common. What happens? m2 minus m1, whereas here a common, m2, this, if you actually move towards to the right direction, minus becomes plus, so this is plus m1. So acceleration a is nothing but now m2 minus m1 by m2 plus m1 into g. So sometimes you will get a problems like this, right? Find the acceleration a. How do you get this one? This is how you can solve this problem. Is it a nice one? Yeah, I agree. Very beautiful concept. Look at here, a consolidation sheet where we have these 4 cases which we reviewed so far. So the hint here is you should be able to draw FBD for a given problem statement and identify all the forces and then balancing them to solve the given problem. So it's very easy if you understand the FBD, how to draw FBD for a given problem statement. Clear? F equal to 5 Newton applied on block B. Let's say this is a 3 kg block. This is 7 kg block, right? So find out a acceleration, a common acceleration. How do you calculate this one? m1 plus m2, how much? 3 plus 7, right? This is called 10 case. You think like this, this is a 10 case block, and then you're applying the force, right? So F equal to ma, because acceleration is always towards in the direction of force. Clear? And hence ma, so 10 into a equal to your 5 newtons, right? So your acceleration a equal to 5 by 10, so 0.5 meters per second square. This is a common acceleration at which the blocks are moving. For a given problem statement, if the force applied is 5 Newton, then find contact force between M1 and M2. So you guys can try out. So I'm leaving this option for you as an homework. Say if you're not able to solve, then probably tomorrow I will figure out. Okay. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Alright, so we reached the end of the session. Thank you all who are actually joined today's class. It's very interactive and then productive. Thanks again. Stay tuned to our next session. I would be uploading this video into YouTube channel. Please feel free to subscribe the channel and share the channel to your friends. Thank you. Stay tuned to next session. See you tomorrow. Have a good day. Bye bye.